Hello everyone, welcome back. In prior videos we discussed regarding the key lifetime and key length, and now in this video let's focus on key hierarchies. So why we go for key hierarchy? This is the key hierarchy is a technique which is used for managing symmetric keys, and this consists of ranking of keys with high level keys being more important than low level keys, and keys at one level are used to encrypt the keys at the level beneath here. So here in the key hierarchy, so there are two advantages of developing keys in hierarchy. One is the secure distribution and storage, and another one is the facilitating scalable key change here. So in the simple key hierarchy is like this is the example. Here we illustrated the key hierarchy where first is the master key. It is the high level secure key it is, and this key is used, okay, and this lifetime of this key is also very long comparatively these two keys, and this is the key it is used for encrypting the key encryption keys here. So key encrypting key is the second level key, and it comes okay, lifetime of this one is less compared to the master key, and this is a little bit exposure to the environment here. So whereas master key it is totally secured, and key encrypting key is little bit it is exposure, and lifetime of this one is long, but it is comparatively if you go for the master key it is lesser than the master key here. Next one is the data key, and this data key is encrypted using the key encrypting keys here, and lifetime of this one is very short and it is more exposure here. So and usually data keys lifetime is the session period here. That's why usually we can also call this as a session keys here. So master keys, okay, this is the higher level and it is probably require the more secured here, and next one is the encryption keys, okay, it is less exposure, and data keys it is more exposure, and usually for data keys we call as a session keys. There are two key distribution approaches to acquiring the shared keys from a key C. Key C is the key center. From the key center you can get the keys. Two distribution ways are there. One is the key translation. In the key translation, first allies will have the data key, and that data key is encrypted using the encryption key, that is KAC. This is the encryption key. With the help of this encryption key, data key is encrypted and it is sent to key center, and key centers will decrypt that key with the help of this encryption key. Okay, so that key after decrypting, once again this key, okay, key centers will encrypt that data key with the help of, okay, KBC, that is the encryption key that is known by Bob here. This encryption key is known by allies, and this is the encryption key known by the Bob here. That's why it encrypts with the help of that key here. When Bob will receive, Bob will decrypt that key, and that Bob will get the what is the key here. In this way Bob will get the data key here. So this is the procedure how you will generate the key here. This is the K is the data key. It is encrypted using the alias encryption key. Okay, and it translate to the key center, and key center will decrypt, and after decrypting once again it encrypts that key with the help of KBC. This is the encryption key of the Bob, and with the help of that key it encrypts and it sends to Bob here. When Bob will receive, it decrypts and it will get that particular key. This is what we call as a key translation. In this way you are sending key data key from alias to Bob here with the help of the key center. Key center acts as a switch. It transfers the key from alias to Bob. Next one is the key dispatch. So in the key translation, key is generated by whom? Key is generated by allies. Allies will generate the data key and it encrypts and it sends. Whereas in key dispatch, so instead of generating the key from the ally side, key center itself generate the key, and that key it encrypts using the allies key and Bob key, and it concatenate the both the keys, encrypted key, and it sends to allies. Allies will know the okay, Alice key, and with the help of that key, Alice will decrypt this key here and Alice will get the key here. And remaining part it sends as it is to Bob here. Okay, Alice will send the remaining part as it is because Alice can't decrypt this key here. So that only it can, okay, decrypts the key with the help of the Alice key here. So decrypting of this key is possible with the help of the Bob key. That's why it simply transfer that key to Bob here. When Bob will receive, Bob will decrypt this key and Bob will get the key here. So this is what we call as a key dispatch here. Next is unique key per transaction schemes here. So unique key per transaction, it is a scheme, is a different way of establishing a cryptographic key, and they establish a new key each time that they are used. Every time, so during every transaction or during every communication, you are getting the new key here. So such type of the key what we call unique key per transaction. And what is the motivation for this? Okay, Ukpt scheme here. It is an alternative methodology used to generate a new keys by deriving them from information already shared by Alice and Bob. Alice and Bob already have the some information. With the help of that information, you are generating the new key here. If key derivation is used to generate a new keys, then the process of key generation and key establishment essentially merges. So here generation and establishment are merged. This brings several advantages. One advantage is what here? So here you are merging the establishment, key establishment and the key generation. Due to that you will have the two advantages. One is that Alice and Bob do not need to store a long-term key here. Storing of the long-term key is not necessary because every transaction you are getting a new key here. And Alice and Bob are not required to engage in any special communication slowly for the purpose of key establishment. As I told earlier, so okay, you have to generate the keys and that key you have to keep securely and you have to transfer that key with the Bob also. Okay, that is what you call as a key establishment. Key establishment means what? You have to send that key to the Alice and Bob securely using the secure channel here. So that special communication, whatever you require, no, that is not required here because here you are performing the key generation and key establishment as a combined here. This is the advantage of this unique key per transaction scheme here. Applications of the scheme. Retail point of sale terminals which are used by merchants to verify pins and approve payment card transaction. So in payment card transaction you are using you have to verify your pin. So for verifying that, what is the thing you will get? For verification you require the pins. Okay, once if this pin is verified, then you will approve the payment card transaction here. So here one example is there for this Ukpt schemes. Consider the scheme operating between a merchant terminal and a host, a bank or a card payment server. The terminal maintains a key register, which is essentially the running key that will be updated after every transaction. So in the key register you are maintaining the key, but that key is not kept as it is, or on every transaction you are updating that key here. And a generic Ukpt scheme in terms of the protocol that is run between the terminal and the host during transaction. It is the transaction between the whom? It is between the terminal and the host here. Okay. So this is the application of Ukpt scheme. This is very simple. If you are making the online banking, as you know that every time you enter your username and password, along with that you will get one thing, that is your OTP. Yes, that OTP is the key here. Okay, for every transaction, or you are using the same OTP or you are getting the different OTP? Yes, you are getting the different OTP for every transaction. So that is that OTP only you are keeping in the key register, and for every transaction you are getting the unique OTP here. So this is the example for this Ukpt scheme here. Is it clear now? Okay, thank you.